Today's video is limits of infinite sequences. Start out with a definition, and that is an infinite sequence is a sequence that has no last term. So up on the screen I have an example for you. The sequence that starts with 2, then 1, then 1/2, then 1/4 is an infinite geometric sequence. We could write this sequence as g sub n equals 2 times 1/2 to the n minus 1. Some sequences have limits, that is, as n gets bigger without bound, a sub n approaches a value. That value that a sub n approaches is called the limit of the infinite sequence. The notation we use, and this is new, is we write LIM for limit, and then a subscript we say as n approaches infinity. So we draw an n with an arrow. Oh, that's really bad. Let me see if I can do the whole thing. As n approaches infinity of the sequence 2 times 1/2 to the n minus 1. And so the idea is, can we find a value? So let's look at these numbers and notice that each time we go to the next term of the sequence, we're cutting the number in half. And so although we never will actually arrive at 0, we're pretty certain that by cutting a number in half over and over again, the number that we will approach is 0. And so we say that the limit of this sequence is 0. Now, some sequences do not approach a value like that. Let's go ahead and look at this geometric sequence. This time, instead of multiplying by 1/2 each time, we're going to multiply by 5. And so the first few terms are 2, 10, 50, 250, and we get the idea with the dots at the end. It's an infinite sequence and it continues to get bigger, and so we would write that the limit as n goes to infinity of this sequence would be infinity, because it is getting bigger. The terms are getting bigger without bound. All right? Sometimes the limit is negative infinity, so let's look at this sequence. We're still going to multiply by 5 each time, but we're going to start with the first term of -2. And so the terms go -2, -10, -50, -250, and so it's pretty easy to see that the limit this time as n goes into infinity of this sequence is not infinity, but negative infinity. Now, just a side note here, we know that infinity and negative infinity are not numbers, but when we're looking at limits, we're not actually finding the value it arrives at. We're looking at the target that it approaches, and so we're saying that as n gets bigger without bound in this one, a sub n approaches negative infinity. Okay, last example I want to look at is what happens if the first term is 2, but now the ratio is negative instead of positive. And so this time, we've seen this before, what happens is that the terms of the sequence bounce back and forth and do something like this. And so if we pictured a graph of this, right? So here is a graph. We go to 2, and then -10, and then +50, and then -250, and what we can see visually is that these terms are bouncing back and forth. They aren't approaching any value, and so this time we say the limit as n goes to infinity of 2 times -5 to the n minus 1, we say the limit does not exist. And for those of you Lindsay Lohan fans, you'll remember this from the movie Mean Girls, and then sometimes we actually talk about this as the mean girl limit. So what we've noticed, let's just kind of sum up from these 3 examples, is that the limit of a geometric infinite sequence depends on the ratio. So the ratio is what holds all the power. And so in the first example, where we looked at 2, 1, 1/2, 1/4, we found the limit was 0. And so the key is that any time the absolute value of the ratio is less than 1. So in other words, the ratio is between 1 and -1. The limit as n goes to infinity will always be 0. Okay? So if the ratio is 2/3, if it's -0.9, any of those fractions that are greater than -1, less than 1, the limit will always be 0 of that sequence. When the ratio is greater than 1, like in the one where we multiplied by 5, where it went 5, 10, 50, 250, we found that the limit was infinity. But sometimes the ratio was greater than 1, and we had negative 5, negative 10, negative 50, negative 250, and we said the limit as n goes to infinity was negative infinity. So for this one, when the ratio is greater than 1, sometimes it's infinity and sometimes it's negative infinity, and in this case we have to look at that first term. Okay? The last one was, if the ratio is less than negative 1, it's going to bounce back and forth. That was this example where it went from 2 to negative, I've lost my answers, 2 to negative 10 to positive 50 to negative 250. We said that the limit as n approaches infinity does not exist. Okay? So those are the rules for limits of infinite geometric sequences. Let's